Okay, guys, just like I promised before, now I'm going to show you how to actually identify reduction and oxidation reactions. Okay, so ultimately what this comes down to is, so let's talk about this first. We're going to balance them in just a bit, but first I want to show you what they are. So redox reactions are the following. Oop. It is a reaction between a reduction reaction and an oxidation reaction. And when I was a young man, I absolutely hated balancing these things. It was such a pain in the butt. It's the first time I took one of these things and I was like, I don't get what to do. So it took a lot of practice, but eventually I got it. And hopefully, eventually, you guys will too. Now, for this is like one of those other things too, where eventually, as I keep saying, eventually, some of you guys are going to get this right away. And some of you guys, it's going to take a little bit of time. But like everything else, practice is key here. All right. So when we first start off this lesson, the first thing I want to teach you guys is this little saying. And people have been saying it forever. It's the way I learned it. Now I'm going to teach you guys this too. This little phrase goes, Leo the lion goes grrr. All right. Oh, that's supposed to be an E. My mistake, G-E-R. I want us to focus specifically on this Leo and on this grr. All right. Because this is what it is. So if we break this down, Leo, right? Leo is a good way to remember that whatever loses the electron, right? In this case, I'm gonna put electron right here. That's what's being oxidized. So if one element or one atom is losing an electron, we say that is the element that is being oxidized. That is the atom that is losing those electrons. And Leo the line goes grr is a simple way of kind of remembering that. I'll put a little line right here because it might help you guys remember. Oh, what are we doing here? That kind of looks like a line, right? That's as best as I can do. All right. So we got Leo the lion goes grr. Now, what about the grr part? Well, just like we did before, G, E, and R. If an atom is gaining an electron, it's kind of hard writing vertically, right? Well, that's what's being reduced. Okay. So if an atom gains an electron, reduced, is it ED? I don't know. Something like that. All right. So if it's gaining that electron, that's the atom that's going to be reduced. Okay. Now, if you're thinking about like what's the oxidizing agent and what's the reducing agent, well, it's just the opposite, right? If you're the one that's causing something to lose an electron, you're the oxidizing agent. And if you're something that is causing or that's giving up that electron, well, you are the reducing agent. Don't worry about that too much. First of all, let's learn how to identify these things. So to kind of help you out with this, let's take a very simple reaction. Well, first, I got my little line up here. That way you guys don't forget what we're doing here. Leo the line goes grr after all. So M right here. Someone taught me how to do this in third grade, and I never forgot. It's kind of one of those things just kind of stays in your brain. What am I doing here? No, I don't want to learn. So get out of here. Get out of here. Uh-oh, my line's gone. Oh well, that was a waste of time. All right. So here's our reaction. We have aluminum. This is actually right out of your guys' nose. This is solid aluminum, by the way. So I'm gonna put a little S right there to let you guys know it's solid. We have some copper ions. Because they're ions, our assumption is that it's aqueous, little AQ. All right. And it's going to react and it's going to produce aluminum ions. You can tell this is probably some kind of single displacement reaction. 3 plus. All right. And this is going to be aqueous as well. This is too easy of one. We should have got a harder one. You know what? We'll do that when we get to the balancing ones. Right now, let's just learn how to identify stuff. We're going to get copper solid. Okay. So step one in figuring out what's being oxidized and what's being reduced is actually assigning oxidation numbers. And if you remember from the last lesson, this is exactly what I taught you guys to do before. So that's what we're going to do right now. So remember that if it's a solid, we're going to start with the aluminum. I always like to start with the reactant side just because I'm weird like that, but that's the ways I always do it. So over here with the aluminum side, right, since it's the solid, we're going to assign it an oxidation number of 0. Okay, pretty simple stuff right here. All right, now over here with copper, right? Copper is all by itself, but it has a positive 2. So its oxidation number is pretty simple. It's just going to be positive 2. Okay, nice and easy. Now let's go over to the product side. Do the same thing over here. Aluminum is positive by 3. How do we know that? Once again, because aluminum is right there with a positive 3. So nice and simple. And copper, all on its own, is going to be an oxidation number of 0. Okay. So what I'm going to do right now is I'm going to figure out which of these two is being reduced and which of these two is being oxidized. So let's take a look. Okay, so let's make this one, let's do the oxidizing one. Let's make it purple. So remember our little saying, Leo, the line goes Gur. If it's being oxidized, well, that's what's losing the electron. Okay, so let's take a look first at aluminum. See what's happening with this guy right here. So aluminum goes from 0 all the way to positive 3. Well, what does that mean? Well, what it means is that aluminum must have gained, or sorry, must have lost 3 electrons, because when you lose an electron, you tend to be, not tend, you become more positive, and specifically positive by 3. So when that's the case, this one right here, from aluminum to aluminum 3 plus, this is the oxidation reaction right here. This is what's being oxidized. This is what's being oxidated, right? So this is the oxidation reaction. Now, if we take a look at copper, I'm going to give this a different color. Let's call this one green, right? Copper goes from positive 2 down to 0. Well, if that's the case, that means that it became more negative because it went from positive to 0, which means that it gained some electrons, right? So if that's the case, this right here, this is what's being reduced. This is the reducing reaction, or the reduction reaction. All right. So therefore, we get both of those things. We figure out which is being reduced and which is being oxidized. Now, first, we start off just to being able to identify what's being reduced and what's being oxidized. The next thing I'm going to show you is actually how to balance these redox reactions. And we'll use this very reaction to actually show you how to do that. So the first step in all of this is obviously assign oxidation numbers. Figure out which is being oxidated and which one's being reduced. And then we're going to break this into 2 half reactions, because in reality, that's what a redox reaction is. And it's 2 half reactions that you're going to combine together to balance. Okay. Because remember, it's not just about balancing the atoms, but it's also about balancing the charges as well. Okay. So what we're going to do right now is I'm going to split them up between a reduction and oxidation reactions. Now, I don't know why, I've just always done it this way. I always write my oxidation reactions first. It's the way I've always done it. Okay, so our oxidation reaction is going to be this one right here. It's going to be our aluminum going to aluminum 3 plus. Let's go ahead and do that. So we have aluminum, which is solid. I'm not going to write the solid part because I'm lazy right now. Just kidding. I just don't want to. I need the space. To aluminum 3 plus. Okay, and I'm going to do the same thing now with the copper ion becoming solid copper. Let's do that right here. Actually, you know what? Let's do it right here. So we have copper ions 2 plus and reacts to become solid copper. Okay, now, just like we said before, we have the oxidation reaction, we have the reduction reaction. Okay, so now what we're going to do is we're going to assign charges. So in order for us to get from 0, no charge, to positive 3, right, that means that 3 electrons were going to be lost. So if 3 electrons were lost, right, that's going to happen on the product side. So I'm going to add 3 electrons over here. Now, the way you got to think about this is each of these sides has a charge. Now, if you think about it, this charge over this side of the reactant side has a 0 charge. The product side has a positive 3 right now. So it's not balanced. Okay. So in order for us to get this balance, this also over here has to equal 0. So if we add a negative 3, right? Well, positive 3 plus negative 3 gives you 0. So now both sides are balanced in terms of charges. So we have to balance them just like that. So we add 3 electrons over to the product side of the equation. All right. Okay, so that one's done. I don't have to balance the matter. The matters are balanced. I have one aluminum on one side, I have aluminum on the other side. The only things that are not balanced are going to be the charges themselves. All right, well, let's get to the bottom part then. So if we have copper 2 plus and copper just regular old 0 oxidation number, over this is going to be positive 2. So right now you can see right off the bat that it's not equal, right? On the reactant side, you have a positive 2 charge. On the product side, you have a 0 charge. Okay, so how do we get them both equal 0? 0. So since this is the one that's being reduced, remember this is the one that's going to be adding the electrons. Okay, we're going to add electrons to it. So we're going to put it on the reactant side. So we're going to add 2 electrons over here. So plus 2 electrons, just like that. Okay, and just like that, now the balances, or the charges are balanced. Everything's good to go. Okay, now here's the next step is, and this is the step that oftentimes confuses students. What do I do now? Well, ultimately, I want to get rid of the electrons, because that's kind of what this is all about. But you notice that I can't. So when I add these two together, they're not going to cancel each other out because this is 2 over here and this is 3. So I got to get them to equal each other. So what do? I multiply them by a common factor. So in this case, I want to get them both to 6 because that's the lowest common factor. So in order for me to do that, I'm going to multiply the top part by 2 to get it to 6. So let's do that. Multiply the whole thing by 6. So it's like I take 2 times 1, which is going to give us 2 aluminums, 2 times 1, which is going to give 2 more aluminum ions. And over here, instead of having 3, I'm going to have 6 electrons now. Okay. Now on the bottom, I'm going to do the same thing, except on the bottom, I'm going to multiply it all by 3. Okay. I'm going to multiply it by 3 because I want to get this 2, right, to 6. So we're going to do it by the lowest common factor, multiply it by 3. So that gives us 3 copper ions, gives us 6 electrons, and 3 solid coppers. Now they're going to be equal to each other. So now what I can do is I can actually go back and I can cancel these electrons. Because at the end of the day, when you balance redox reactions, you want to cancel your electrons. You don't want them to be part of the balanced chemical equation. So those are gone because those are equal to each other. Because you got to think of this as a split line between the equations, almost like an equal sign. So if they're equal on both sides, I mean, they're just going to cancel out. So that's what you want to end up doing. And that works with everything. All right. Do the same thing on this side. That's going to cancel out. All right, so that part's done. What comes next? What comes next is I have to add up all of my elements to give me one solid reaction. I'll make this a little bit smaller so I can actually fit all this crap right here. Put it right there. And I'm going to add them up. So now that I got that, I'm going to add up both of my compounds, or both of my half reactions to get one full reaction. So let's add them up, right? We have 2 aluminums plus 3 coppers, copper ions, that is. Oh, try it one more time. Cu. There you go. There's nothing else left over. Then I got the reaction. Add those up. Then I got 2 aluminum ions plus 3 copper or solid coppers. Oop. Try it one more time. Cu. And there is our balanced redox reaction. Just like that. So, like I said, when it comes to doing all of these, remember one thing. Remember to identify what's being reduced and what's being oxidized by assigning those oxidation numbers. And then after that, it all just becomes a part of not just balancing the matter like we've been doing so far, but also balancing the charges. And that comes down to adding electrons to either side of the reaction. Split them into half reactions, figure out which was being oxidized, which was being reduced, right? And then simply just adding those electrons. Okay. Typically, what happens is the side that's being oxidized, the electrons are added to the reactant side. Or sorry, let me say that one more time. The side that's being the reaction is being oxidized. Typically, electrons are added to the product side of the equation. That's like this one. Or if it's being reduced because you're adding electrons, typically added to the reactant side of the equation. Then all I simply do is just add them all up to make sure all the electrons are canceled. And it gives us our final balanced chemical equation. Now, I like to tell you this is as simple as it gets, but in reality, we're going to start doing these things in acid and acidic and basic solutions, which makes this just a little bit more difficult, right? Just a little bit more, because you got to do a couple of extra steps. Now, the acid ones, this is a little bit simpler than the basic ones. Basic ones can be kind of a pain in the butt. So that's what my next video is going to cover. I'm going to do those separately, not as one big old video. So that way you guys can watch one part, pause it, and then watch the second one. All right, guys, I hope that helps. If you guys have any questions, please let me know.